Can we learn from the past? If you wanted to rate, on a scale of 1 to 10, Britain's energy industry's capability to learn from the past over the last 50 years, not dream about the future or design ways forward for great innovation, but to learn from the past. Scale of 1 to 10, with 1 being non-existent and 10 being absolutely outstanding world leader, where would you put it? How many ones? 3? 5? Don't be shy. 7? 9? There is no such thing as 10. You're about right. It's about 5. I think if I were going to describe as an outsider to the industry as I was in 1988 when I emigrated to America, to the UK, I didn't see much learning taking place. Now, I've got to qualify straight up front. I'm not an engineer, and I'm not an executive or an accountant or a governance person. What I am is an operator, and an operator is slightly different in their makeup to people who design and engineer and construct and commission. An operator is the end user, so effectively I see an operator as a customer who has to take a bundled bit of software or a bit of mechanical electrical kit or a good design or a poor design and then run with it for the design life of the whatever it is he's operating or she's operating. But can I just say that it's this triangle of influence that we need to remember when we're starting projects from the very beginning. It's not just an investment. It's not just a design opportunity for the pursuance of excellence. And it's not just an end user piece of equipment that we're going to deliver for a bunch of operators to operate at 3 o'clock in the morning when everybody else is sleeping. It's a combination of those 3 things, and those 3 things come together to form what I would refer to as program management. Program management and good program management has all the elements of what's important to a project and to the individual project streams that fit in to the overall program. My experience at Sizewell B tells me that you could look at Sizewell B externally and you could classify it as a huge success. By another set of measures, you could classify it as a huge failure. But somewhere in between is the truth. And I hope to just show you today a few of the things that we can learn from to make sure that any major infrastructure project we take forward into the future learns from the experiences of Sizewell B. It was the last real major commercial nuclear power project that we've completed, and I understand, if you're involved in decommissioning, there's been some huge and great successes in the design and construction and eventual operation of decommissioning plants right across the UK. But from an operational point of view, from the one that most of the public sees as nuclear power, Sizewell B was it, and that was basically nearly 25 years ago, depending on where you put the start point. So that's what I'm going to try and cover in 25 minutes or less. Just said that, but I'm going to cover some licensing issues, some planning issues, reactor building construction issues, and some summary lessons. And what's interesting here is that 22 years later, the parallels can still be drawn. Relatively, and I think the older colleagues in the crowd will agree that we're still struggling with licensing, planning, design, construction, and buildability. Now, those are the key issues that when you look at the projects around the world that are being built, Olkiluoto or Flamanville or Taishan or other Chinese units, particularly from an EPR perspective, which is what I'm directly linked with at the moment, these issues are key issues. Certainly in the free world, I say the free world, but you know what I mean. Some places get things done really quickly from a planning perspective, and others have to consult and reconsult. The countdown to Sizewell B, this was the picture in 1985. Application had been submitted. It had been in submission for 4 years. An inquiry was started in 1983. Consent in 1987 was planned. Remember, we're in 1985 looking at this when this slide was produced. Construction started in 1988. Fuel loaded in 1994, and commercial operations in 1995. The interesting thing is that at 1985, the plant to be built was already 5 years old on paper. largely unchanged through the sort of application and inquiry process. But for those that were involved, you realize that Sizewell B grew to be a one-off standard plant. And I'll cover some of that in a minute. But the interesting thing here is you've got almost a fully fit design and construction team being built in 1985. And if you knew then what we know now by looking back, that consent wouldn't be granted for eventually 2 further years, and a construction starting for 3 years from 1985, you know, you might have realized at the time the challenge ahead of you. And the challenge was, how do you keep an established workforce motivated, you know, up to speed, current with what's happening, at the same time not try to outspend your budget by keeping so many people on hand that you don't really need. And certainly in the early days of Sizewell B, prior to construction starting in 1988, it was about trying to keep people busy and engaged and positive. If you look at licensing, Sizewell B, the acronym there is SNUPS, and it was a standardized nuclear power plant system. It ended up being a unique one of a kind. So it's not really standard other than it is a Westinghouse plant. It's a PWR 4-loop. But the British then took that and redesigned it, and through regulation and consultation, additional safety systems put in place, 2 turbines instead of 1 on most PWRs. So it's quite a different plant to eventually operate than your sort of standard nuclear power plant system. Today, while we're looking at either an EPR or an AP1000, Westinghouse or Areva, plus a bit of UK, it will always be specific in certain ways due to the site location or due to the operator's requirements. But the bottom line is we should be pursuing this repeatability aspect of new nuclear in the UK with some diversity in design such that we have, you know, we're not completely reliant as a country on one design. The big issue with Sizewell B was transferring from the ASME codes to the sort of British standards, or accepting of the ASME codes as it finally happened. And what a lot of people don't see was just the move from imperial measures to SI units. It was a huge deal. I mean, I still don't understand SI units. And I still think in foot-pounds force and stuff like that. So this newtons per fortnight, I've got no idea what it means. And I'm like a Welsh speaker in an English environment. I have to translate back to imperial measurements and then convert it back in my head to SI units to communicate. And when I was a control room supervisor at Sizewell B, I can remember just doing that constantly. And it was quite difficult. So to try to get an organization to, like Westinghouse, the designers at the time, to completely convert everything that they needed to deliver to SI units was quite a challenge at the time. Now we've got an element of internal regulation. Back in 1985, the NII was interested in, you know, diversity of shutdown and you know, safety case compliance, ASME codes, SI units. Today, they're working in unison with other regulators, the Finns, the French, the United States. And they're forming a more collective, cohesive view of what is acceptable in design terms for the future generation of nuclear power stations. In Sizewell B times, it was incremental approval, so you didn't get regulator approval up front for the design of your plant. You got interim approvals to start pouring the concrete, dig the hole, pour the concrete, you know, build the shield walls, and it was all incremental. Design of the reactor protection systems, C&I and all that was incremental. What we're trying to do today with the GDA process is to get that agreed up front. At least, should I say, 90–95% agreed up front, under the expectation that as you go through the build process, design changes will have to be undertaken. But the vast majority of consultation and approval for the designs going forward should be approved through what's called the generic design assessment. Currently, the EPR and the AP1000 are both going through that process. And then an issue, I think, was just probably is always going to be an issue, because the one thing that changes more in life than anything from a design perspective, certainly in the 20th and into the 21st century, is control and instrumentation and our reliance on computers and software to do a large part of our thinking for us. Really, you know, affects probably more than mechanical, electrical, or civil, any other aspect of the design and construction process. C&I today on the EPR that certainly we're looking to build, or EDF are looking to build, or the AP 1000 that Westinghouse are looking to build, you could easily see being completely out of date in 10 years' time in terms of modern sort of equipment standards. Whereas with concrete or rebar or pipes or valves, it's probably not the case. So C&I will always be a topical issue for complex systems. Planning is planning. I wish we could come up with another word for it, but planning is painful. And I'll tell you why planning is painful. Planning is painful because it requires upfront work. It requires real focus and dedication as to whose permission you're trying to get. Who are your stakeholders? Who is really important for the success of your project? And it's not always the government or the politicians or the local councilors. Sometimes it's local businesses, local stakeholders, the woman who lives next door and has always had a certain view. It's the whole spectrum of issues from national through to local planning issues. Certainly in Suffolk, that was a big deal. That was a real big deal. And Sizewell and its construction and now its operation had a huge impact on the local community in Leiston in particular. And anybody who was there during the time will understand just the amount of work we could have done keeping the local public engaged. And it's probably an area looking back where me as an individual, I would be proposing that we do a lot more. Because keeping the locals on board and understanding what's happening is absolutely crucial. But there's some similarities, and I just used the EPR here. I could not have. But Sizewell B was a program of 4. Interestingly, the joint venture that ourselves and EDF are involved in is a program of 4, 2 EPRs at Hinkley and 2 at Sizewell B, C rather. Back in 1985, planning pretty unrestricted timescales. It took what it took, and it was really down to the applicants to push the process through. Now we're looking at this thing called IPC, Infrastructure Planning Committee, and this sort of major infrastructure planning sort of umbrella under the national policy statement. So there's some kind of tacit approval, not the right word, but this expectation on political grounds that new nuclear is necessary to meet the company's low carbon obligations going forward. There are sites that are prioritized to be used, and there's an organization put in place to take in and assess all applicants for major infrastructures, of which nuclear and energy are but one. Back to Sizewell B times, it was a national decision. Here, I would say it's as much a national decision as a local one. The locals will not have a nuclear power station imposed upon them. That's not how it will turn out. In fact, I think it would be a real crime and a failure if it did. Because there's no need for it to happen, because most forward-thinking, informed individuals at whatever status or level in the population understand that in order to succeed as a low-carbon economy, you have to have nuclear as some sort of component of that, and safe nuclear is the key. And so locally, I think we find, and certainly at the sites, and it won't surprise any of you, that the locals are generally very supportive of our activities. And that's down to the great legacy that our power stations and operators have left behind over the past 40 or 50 years. Public inquiry at Sizewell B took 6 years for a decision. That's a long time. That's hard to keep motivated. It's also hard for a design because things move on. And here now we're looking at about, and it's a big about, but 2 years for a decision going forward on new nuclear, which would be a big improvement. One thing that does do behind the scenes for all you executive and finance and people back there, that really closes the risk window. It starts to give certainty, and when you add planning certainty to an energy market review and reforms that can make new nuclear compete on the low carbon terms, funded decommissioning approvals, you start to get an environment in which investors can make new nuclear build decisions against the backdrop of significantly reduced risk. This is where I started to feel old. Look at these pictures. You know, this was 1991, 1990. The hole's starting to be dig at Sizewell B. You know, they didn't have PowerPoint back then, so these were actual photographs around the site and in the newspapers. But you can see there's, you know, logistically, it's a big deal. You know, it doesn't become a nuclear reactor until about 4 or 5 years in. Up until then, it's just metal versus concrete every single day. Metal versus concrete every single day. And then the electricians come in, and it's metal encased in insulation versus concrete and metal. And that's when you see a construction team on a new nuclear plant, they're largely metal people fighting concrete people, fighting installation people. And that's what it's all about, is this, who's going to win today. From a program management point of view, we need to reduce that back to lowest terms and say, you know, wherever we can, we need to blur the boundaries between civil and mechanical and electrical and get partnership working where we can to understand that once you're finished as a civil contractor, you've got to up sticks, get out of the way, and make room for the mechanical installation contractor. And once you've got your bed plates in, you've got to up sticks, get out of the way, and let the electricians in to pull cable. And once you get done, you've got to up sticks. There is no permanent home on a nuclear power station. You're in, you finish, you're out. The next person comes in and does their bit. And that mentality can be hard to develop when people are entrenched and sort of averse to change. And so our contracting strategy, procurement strategy, program management strategy needs to envelop that and be right up front with what we expect from our partners going forward in terms of constructing new nuclear. And it is a partnership. There is tier 1 and tier 2 and tier 3. But at the end of the day, the people who are successful in carrying out the builds on these projects, they will effectively be working in partnership with the owner-operator. Talked about planning and licensing and all that. There's a lot that can be done before you ever get planning permission. So as long as you're not pouring nuclear concrete, the regulator isn't involved to a large extent, and it's basically a planning issue. So if you can convince local planners to give you permission to proceed, there's lots you can do. I mean, at Sizewell B, there's literally millions of tons of earth which had to be moved and shifted. Bed plates for stopping erosion, concrete pours, you know, just a massive amount of pre-work that can be done. The difficulty is that this pre-work is also pre-FID work, so it's pre-investment decision work, so it's at risk. So if the design doesn't come through or ultimate planning permission doesn't happen, all this work that you've done suddenly becomes, oh, we got to put it back together again. We got to make it like it was before we started. So, you know, you look at that and you say that's probably 35 million pounds worth of moving dirt around. You've got to look at that as 70 million pounds because there's a chance you're going to have to put it back together again. So from an investor's viewpoint, that's a big deal when you're not getting any return back on that. So as much risk as you can minimize up front, the better. This is another one that made me old. You know, there was actually teams of people that just made cardboard 3D models, and I mean literal 3D models of Sizewell B as it was being constructed. And this is just cardboard. But there was old guys just sat there just with their, you know, knives and building this. But this was day one. You would expect day one to be dirt. But in actual fact, day one at Sizewell B was quite well progressed. So quite a big amount of risk had gone into the project pre-planning consent, pre-construction consent. A large part of that is down to the fact that the money was, you know, the money was probably government provided. In today's climate, I don't think we'll see that level of pre-FID spend or construction. But what we will see is well thought out and well risk-based investments starting at Hinkley Point in the pretty near future, if things continue the way they're going. This is just, I talked about metal versus concrete versus electrical. This is just a typical valve cell at Sizewell B. It's the high pressure safety injection system down there on the bottom, a bit of low pressure and component CVCS, it's called charging volume control system. Primary containment wall at the top and some more pipes and stuff at the top there. You know, this is meant to illustrate that you've got this times about 400 similar sorts of little pipe and valve galleries. And it is a battle for space, a battle for safe space, simple as that. Each organization knows what they have to do, but the logistics into getting them in there and capable and able to do that is very, very difficult, and is really just good construction program management. I put this slide because we can't forget. I mentioned that the nuclear site doesn't become a nuclear site till about 5 years into the build. You start putting the core and the NSSS, you start thinking about loading fuel. But from a long-term perspective, 60 years plus construction, it's a nuclear power station. And it's a nuclear power station that has to be built to the highest standards of safety and quality. So that is a given, safety and quality. And I would argue as an operator that program and cost are variables. Now, good program management seeks to control program and cost in line with the minimum acceptable safety and quality standards. And that is the program management dilemma that we go through every single day when building, designing, constructing, and operating new nuclear power stations. And indeed, the AGRs which are currently operating still go through this model. Program and cost are variables, but safety and quality is the given. If we had it any other way, the NII would never let us operate. Quite right, too. It's the same with an airplane. I don't know if you can all see it, but at the height of construction, there were about 17 tower cranes. There were 4,500 people on site, a combination of concrete, metal, and electrical. CNI came in at the end. At this stage, one of the interesting things, the operations teams were actually being hired and trained. So quite early on in the process, the eventual owner-operators of these things were brought onto site and allowed to see the construction process that was taking place. But you can just see the logistical nightmare. I mean, this is tough going. You've got 4,000 people coming to work 6 or 7 days a week trying to get to their work area. And it really does come down to good site organization, safety culture, and program management. This hump is the extended workforce. It was originally spent like that. In the real eventuality, it was extended because of difficulties at Sizewell B in redesign of the CNI systems and just pure logistical reasons, trying to get enough people into the right workplaces at the right time, which meant that you effectively had nearly 5,000 people in place for twice the duration that the original plan assumed. So locally, we had conditioned the locals to say, well, we'll have 5,000 people on site for about a year. No, that was wrong, Leiston. We now have got 5,000 itinerant contractors in place for 3 years or 2.5 years. That dramatically changed Leiston and its outlook on Sizewell B. Not because contractors are bad people, they just have different expectations than people that live there their whole lives. And they go out and do things with loads of money in their pocket. Rebar, I talked about this. It is a conflict between metal and concrete, and don't kid yourself if you think anything different in the early days. But there's 2,000 tons of rebar in the reactor building base at Sizewell B. That's a lot of rebar. And the density there is 860 kilograms per cubic meter. That's a lot of steel. It just makes moving around on your feet difficult, let alone trying to pour concrete and run pipe runs and lower heavy loads and everything else. Again, you can see the access. This is the joint between the reactor ox building and the containment liner. This had to be replanned several times just due to pure logistics. And due to time constraints, what they ended up doing was building temporary weatherproofing such that the mechanical and electrical guys could work underneath the civil guys, which brought with it not only inclement weather considerations, but dropped objects and people working above each other. And a whole lot of site logistics work had to go into making sure that the place remained safely and on time. I've been on 7 construction sites for new nuclear power stations in my 35 years, and every single one could have used more cranes. You hear it every single day. I can't do that, boss, because I can't get a crane. 17 tower cranes, an uncontrollable number of mobile platforms and lifts, and you still can't get enough cranes. So when you're looking at laying out a site, you really need to make sure you've got, you know, the same area covered 3 or 4 times over by craneage. I know EPR is particularly difficult in that area. I'm not sure about the AP, but I'm sure Adrian can give us a sign. But, you know, up front, we really need to look at our craneage coverage. This is construction access closure. Again, it doesn't really show you anything other than stuff inside, stuff outside, and the extent to which it was incomplete on the outside. So at the same time you're finishing the outside, you're starting to put stuff inside, over the top, into the construction hole. Lifting, access, safety is all a key issue right up until the day that this construction access is closed for the last time. And after all that, they still claim Sizewell B was on target and within budget. But, you know, it's a big ask, but it was 76 months versus 63 based on planning and consenting. It was 2.03 billion versus 1.87 billion, largely due to the delays and the extra staffing for that 2.5 year period at full manning. But at the end of the day, the quality standards were such that the plant has been able to operate for the last 20 or so years, you know, at exceptionally high availability, with 1 or 2 relatively minor events over the last 15 years. But when you look at Sizewell B and the fact that it's a one-off, operated in the UK, surrounded by technology of which there's nothing that is like it, you know, it's a testament to the upfront planning, the sort of cardboard cutout people, the lack of PowerPoint presentation materials, and, you know, in-depth sort of planning materials. We didn't have P3, we didn't have Microsoft Project, we didn't have any of that stuff. And at the end of the day, a group of people turned out a reactor that I think the UK can be very proud of, and also use as a benchmark going forward. This is Greg Evans' things to remember about program management. Government public support, you got to get it, you got to keep it. That's safety and quality, and communication. Design established and approved. It really helps if you know what you're building when you start. Planning certainty, nationally and locally. Keep the locals on board, and the nationals will look after you. That's the order of priority. World-class program project management processes. This is the area we need to learn the most about, because we don't know about it yet. We got to get a lot better. We got to do T5 about 20 times. Terminal 5. That's the equivalent of what we got to do. Clearly defined procurement strategy. Yeah, let's have that, because that really defines how we're going to work on site as a family. Knowledge transfer. Be able to and willing to hand over what you know to the next team that's coming in quickly, whether it's construction, commissioning, operations, mechanical, electrical, concrete, whatever. End user training's got to start early. Get the operators on board and let them know what you've built into the thing. Give them a view of what it looks like as a skeleton before you put the meat on it. Keep it clean, because you only have to clean it up after. Keep it safe. That helps keep locals and planning on board and the government on board. Keep it defect-free.